Good evening, this is Miss Seow here, and today I'll be covering ratio word problems for Primary 5 and Primary 6 students. Let's take a look at a quote before we start. By Harry Wong, he says, "You should not only know what you are doing, you should also know why and how." This is very important in maths because when we know why we do something and how we get it done, then maths is not something that we solve using a memorized method or a sequence of steps that we just blindly follow, but something that actually makes sense from start all the way to the end. Yeah. So before I go into the 5 questions of ratio, the questions are taken from this book called PSLE Mastering Mathematics Problem Sums from Casco by Leanne Goh. Let's start. Now question 1. In the box, the ratio of the number of pens to the number of pencils is 3 to 4. The ratio of the number of pencils to the number of erasers is 5 to 6. Find the ratio of the number of pens to the number of erasers in the box. So just by looking at the first sentence, we can tell that pens to pencils gives a ratio of 3 to 4. Okay, and if we were to compare pencils to erasers, the ratio is 5 to 6. Now what do we notice? From these two comparisons, pencils is being repeated. We do know that the number of pencils remains the same whether it's in the first comparison or the second comparison. However, the number of units mentioned for pencils here is different. How do we then make the units here the same? We have to look at the unit of 4 and the unit of 5 and see what common multiple we can change 4 and 5 into to make it common. So 4 can be 20 by multiplying it by 5, and 5 can be 20 by multiplying it by 4. Same goes for the comparison of the other two quantities. So for pens, we must also multiply it by 5 to make it 15 to 20. And for erasers, I multiply it by 4 to make it 20 to 24. Now that we have the same unit of pencils for each comparison, we can say that we can say that pen to pencils to erasers is 15 to 20 to 24. Now the question asks for the ratio of pens to erasers, and thus our answer will be 15 to 24. Now this is not our final answer because you realize that for each of the quantity here, it can be further simplified by dividing both numbers by 3, and that will give us 5 to 8. Next question. Now let's take a look at it. Mary's height is 2/3 of Claire's height. Nancy's height is half of Claire's height. Find the ratio of Mary's height to Claire's height to Nancy's height. So in the question, they mention Mary's height 2/3 of Claire's height. 2 units go to Mary and 3 units go to Claire. 1 unit goes to Nancy. 2 units goes to Claire. So if you were to compare Mary to Claire, our ratio will be 2 to 3. And if we were to compare Nancy to Claire, our ratio will be 1 to 2. Similar to the previous question, Claire appears twice in both comparisons, in both cases. In the first case, Claire has 3 units. Second case, Claire has 2 units. So since Claire is the same person, therefore the units for Claire need to be the same. But how do we make the same unless we find equivalent ratios of the two ratios? So between 3 and 2, a common multiple will be 6. So in order to give you 6, I have to multiply the first ratio by 2 throughout, and the second ratio I need to multiply by 3 throughout. Okay, and what I will get is 4 to 6. The second ratio will be 3 to 6. Okay, therefore, Mary to Claire to Nancy, Mary will be 4 units, Claire will be 6 units, and Nancy will be 3 units. Okay, so this is the answer for A. Now for B, if the total height of the 3 girls is 364 cm, find Nancy's height. Let's find total units based on A. So total units will be 4 units plus 6 units plus 3 units. That gives you 13 units. And this is 364 centimeters. We can find 1 unit from there. So we have 364 divided by 13. We will get 28. And since the question wants us to find Nancy's height, Nancy has 3 units. So 3u will be 28 times 3. And that gives us a height of 84 centimeters. Next, we move on to question 3. Question 3 says, Tim and Amanda shared some stickers in the ratio 3 to 1. Tim had 2/5 as many stickers as Carol. If Carol had 52 more stickers than Amanda, how many stickers did the 3 of the children have altogether? So, based on the first sentence, Tim to Amanda is 3 to 1. Between Tim and Carol, in the second sentence, we know that Tim has got 2 units and Carol would have 5 units. So Tim and to Carol, 2 to 5. Okay, now which is the name that repeats in both ratios? Tim, right? So if Tim has 3 units in the first ratio and Tim has 2 units in the second ratio, between 3 and 2, our common multiple will be 6. Therefore, in the first ratio, to get 6 units for Tim, I must multiply it by 2. And to get 6 units for Tim in the second ratio, I need to multiply it by 3. And my equivalent ratio for both ends will be 6 to 2 and 6 to 15. Okay, now let's put the 3 quantities together. Tim has 6 units, Amanda has 2 units, and Carol has 15 units. Now we compare Carol and Amanda. The difference is 52. Carol, Amanda, the difference. Let's take the difference between the two of them. We'll get 13 units, and this will be 52 stickers, which brings us to 1 unit equals to 52 divided by 13 equals to 4. And how many stickers did the 3 children have altogether? Let's find total units from this. Okay, this will give us the total number of units, and the total number of units will be 6 plus 2 plus 15 will be 23 units. So since 1 unit is 4, 23, sorry. Okay, let's try again. Since 1 unit is 4, so 23 units will be 4 times 23. And that will give us 92 stickers. Fourth question, the ratio of the number of men to the number of women on a cruise ship was 5 to 2 at first. After 280 men and 280 women went on board the cruise ship, the ratio became 4 to 3. How many men were there on the cruise ship at first? Now, first and foremost, notice that this is a before-after question. So let's have the ratio before and the ratio after. Okay, so we've used this first piece of information and another piece of information. How do we then make use of this piece that says 280 men and 280 women went on board? Now you realize that the same number of men and women went on board the cruise ship, which means that if I were to compare the difference between the number of men and women before and the difference between the number of men and women after, it has to be the same. So this is also a question of constant difference. Okay, let me add something to the ratio. I'm going to include the difference between the number of units of men and women, which is 3 in the first ratio, and 1. Now, since the difference between men and women is the same, therefore, it cannot be 3 units in the first ratio and 1 unit in the second. It has to be the same. So in order to make it the same, let me multiply the second ratio by 3 to get an equivalent ratio such that the difference is 3 units. Okay, and by doing that, I will get 12 to 9 to 3. Okay, now that the difference is the same between the first ratio and the second ratio, we can now compare the values, the units between men. From 5 units, okay, 280 men entered, and it went up to 12 units. So 7 units of men actually entered the cruise ship. Let's compare women. From 2 units, it went up all the way to 9 units. Hey, it's no surprise that it also went up by 7 units. So what does this say about 7 units? 7 units is 280. So 1 unit is 280 divided by 7 gives us 40. Now, question asks you, how many men were there on the cruise ship at first? We have so much of information here. What do we look out for? Men on a cruise ship at first would be looking at before, men, and the number of units. So if 1 unit is 40, we can find the number of men on the cruise ship at first, which is 5 units. So we have 40 times 5, which is 200. Let's take a look at the last question. Question 5. The ratio of the number of boys to the number of girls at the book fair was 3 to 5. After 12 boys and 12 girls left the book fair, the ratio became 4 to 7. How many girls were there at the book fair in the end? Now, again, this is a question of before and after. And in the second sentence, where it says 12 boys and 12 girls left the book fair, it suggests that the concept used to solve this is also that of constant difference. So let me just put down before and after, as well as the concept. Right, and our ratio of the number of boys to girls before will be 3 to 5, and the difference is 2 units, and after it will be 4 to 7 to 3 units. Now, if we were to compare the difference in both ratios, you'll realize that the numbers 2 and 3 here have a common multiple of 6. And in order to find equivalent ratios that have a difference of 6, the first ratio has to be multiplied by 3, and the second ratio to be multiplied by 2. And in doing so, our equivalent ratio will be 9 to 15 to 6, and the next one 8 to 14 to 6. Now, let's compare the units for boys before and after. From 9 units, it went down to 8 units, so that's going down by 1 unit. And for girls, 15 units, it went down to 14 units, so it also decreased by 1 unit. So what does this say of 1 unit? 1 unit is actually 12. Okay, and from the question, they ask you how many girls were at the book fair in the end. In the end suggests that we need to look at after, girls, and from there, the total number of units that they want us to find is actually 14. Now let's not get confused with the wrong units. At first, the ratio of girls in the second ratio is 4 to 7 to 3, but we cannot use 7 as the number of units we want to find because this is not the equivalent ratio whereby the difference is 6 units. So we need to use this second ratio, this equivalent ratio, where the difference is 6 units to get the answer to the number of girls in the end. So 14 units will be 14 times 12, and that gives us 168. I hope that through the 5 examples here, it will give you a better idea of solving questions on ratio. If there are any questions, you may approach me via WhatsApp or private messaging, and I will get back to you again. Thank you.